Now please turn to page 21. Let's try this question. Question number 17. Magnesium dissolves in excess sulfuric acid. Again, please highlight excess. And heat is given out during the process. 3 setups were investigated under different conditions as follows. First of all, write down the equation for the reaction. Magnesium reacts with sulfuric acid, magnesium sulfate, and hydrogen gas are produced. Let's look at the first diagram, diagram A. There is a stopper, okay, at the mouth of the flask. That means, can you tell me under what condition is this reaction carrying out? Under constant volume, because the volume doesn't change. Let's look at flask B and C. Both are in open system. That means both are under constant pressure. Both are under constant pressure. Understand? Because the conditions, they are under constant pressure, so you are measuring their enthalpy change. Enthalpy change. Understand? So let's try A. Explain the difference in heat released from setups A and B. Setup A and B. First of all, let's look at setup A. For setup A, the reaction occurs under constant volume. Okay? Heat is released during the reaction. Okay? And no work is done. No work is done. All the energy released change to heat. Do you understand? So, setup A release more heat. Now, sorry, I repeat. Okay? Now you mark down the answer. Setup A releases more heat as the reaction is carried out under constant volume. However, for setup B, the reaction is carried out under constant pressure. Some energy in setup B is consumed to do work on the surrounding, because the gas is formed, which is the hydrogen gas. In order to maintain constant pressure, part of the energy is consumed to do work on the surrounding. It is not the case in setup A. All the energy released is transferred to heat. So, setup A releases more heat. Now I give you the answer. Now, here, setup A releases more heat as the reaction is carried out in a closed system or under constant volume. Setup B is open to the atmosphere. In other words, the reaction is carried out under a constant pressure. Some energy is consumed to do work on the surroundings. Do you understand? Now let's try setup B and C. Setup B and C. Both reactions are carried out under constant pressure. Okay? And bear in mind, here the difference is we have 5 grams of magnesium. In this situation, we have only 2 grams. Now, let's look at this sentence again. Magnesium is the limiting reactant. Magnesium is the limiting reactant. Okay? A smaller amount of magnesium is used in setup C, so very obvious. Less heat is produced from the reaction. Do you understand? Now I repeat. First of all, please mention both reactions are carried out in an open system. This is the first point. The second point. Magnesium is the limiting reactant. Therefore, a smaller amount of magnesium is used in setup C than in setup B. Less heat is produced in setup C. Okay? Therefore, heat released in setup C is smaller. Hence, last one. Hence, arrange the above setups in increasing order of heat released. Increasing order. That means start from the smallest one, which is setup C, okay, because it used the smallest amount of magnesium. Next one is setup B. And then, sorry, I used the wrong sign here. And then lastly is setup A. Because setup A, the reaction is carried out under constant volume, no need to do work. No energy is consumed to do work because no work should be done.